Hello. Let's talk about circular motion for grade 12 physics. When something's moving in a circle, it has a velocity, it has an acceleration, there are forces involved. If you remember from grade 11, anytime you change the direction of motion, it requires force. So an object moving in a circle is constantly changing its direction of motion as it orbits around the circle. It constantly requires a force in order to move that. Now let's take a look at an example here right away to see if we can figure this out. Let's say you have a ball on the end of a rope and you're swinging it in a circle and it takes 2 seconds to go through the circle. Well, I have here a distance or a length or something like that, and I've got a time here. I'm looking for a velocity. So can I figure that out using the formulas I already know? Well, if I take a look at this and I say, well, my ball is moving in a circle like that. Ooh, look at that, perfect circle. The length of the rope is 1 meter. That would imply that my radius is 1 meter. Okay? The path that the ball actually takes around the circle here is going to be the circumference of that circle. If you remember, the circumference is 2 pi r. So that's the distance that the ball is actually traveling around this circle. So if I have a ball here and it's going this way, it's going 2 pi r. And in this case, 2 times pi times 1. I also have a time. So in this case, my time is 2 seconds. And looking at this, if I use my old velocity formula, velocity is distance over time, which you remember from grade 10, well, my circumference here is a distance. And this here is my time, so I could figure this out. However, circular motion is a special case where we have a repeating pattern. Remember back from grade 11 physics, a repeating pattern in waves, well, the time it takes to go around that, if it's going repeating that pattern every 2 seconds, we're going to call this the period, or how long it takes to repeat that pattern. So the period of motion is how long it takes to repeat that pattern. So in this case, I have a period and I have a distance that it travels here. So I could figure out my velocity by combining those. If I look and do a little bit of algebra here and substitute things in, what I can get is my circular velocity, the distance, which is the circumference, so 2 times pi times the radius, divided by the period or how long it takes to go around this circle. This I can now use to figure out the velocity of this ball. I could go from here, but we're going to use this formula a lot. So my circular velocity is 2 pi r divided by the period. And I have a radius of 1 meter. I have a period of 2 seconds. And I can plug this in by going 2 times pi times 1 divided by 2. And entertainingly, I don't even need my calculator for that because my 2's cancel out. And my circular velocity in this case is 3.14 meters per second. There's my circular velocity. It's great. One thing to note, this is my circular velocity if I have the period or how long it takes for the ball to go all the way around the circle. If I'm looking at my frequency, which if you remember back to grade 11 physics, frequency and period are related. So if I look and say my frequency is 1 divided by period, I can combine these two here and get another version of this. So my circular velocity formula is 2 pi r f, or 2 times pi times the radius times the frequency. And again, a reminder, period is the time to repeat, or how many seconds it takes to repeat the pattern. The frequency is how many repetitions per second. Okay, how long it takes to repeat once, or how many times you can repeat in 1 second. These formulas, you might want to look back to grade 11 physics. There's a little bit more formulas that you can look at there that will be helpful for these, because there's actually stuff, and it's the same concept as waves, except instead of a wave going by, we're doing a circle. Same idea applies though. I hope this has been helpful, and we'll take a little bit more look at circular motion in the next video. Have a great day.